Hello, everyone. So we have a MATHCOUNTS problem here. So this was 2023 MATHCOUNTS state sprint run, number 25. So what is the largest 2-digit prime factor of this quotient? So we have 3 factorial divided by 2 factorial times 100 factorial, which is, 200 factorial times 100 factorial, which is not really easier to deal with, especially if you don't really like cell understanding of like finding the number of divisors for factorial numbers, right? So let's go ahead like and start maybe with the largest 2-digit prime, so which is something we want to actually know. So the 97 is the largest one, and then we have 89. So 91 is not prime, so that's common mistake. And then I have 83, and then I have 80, actually 87 is not, so we will get 79. So you can kind of list them if you want to, right? But let's actually think about what's going on before we list everything. So, 97 is the largest one, but is this achievable? Like how many 97 in this number, or how many 97 in this number, how many 97 on this number? So let's go ahead and kind of list them. So if you divide like 300 by 97, it's gonna be 3 times, right? So you can just multiply this by 3, which will be, I guess, 21. That's 27, 29, 291, which means like if you want to kind of list them, let's go ahead and kind of understand what I'm talking. So take 300 factorial. Okay, so that is just 300, 299. And you can just multiply a bunch of numbers, and then you have 291. And then you can just continue listing. And if you double this number, so that will be 14, and then 18 plus 119. So that will be 194. So if you just listed those, and then you get 97, and all the way to there, like 3, 2, 1. But why I did this way? Because the 291 is just 3 times 97. I just multiply by 3. And then 194 is just 2 times 97. And then this is just 1 times 97, right? So meaning that in 300 factorial, right, when you write this, all the numbers as a product, so you do have 3 factors of 97. So you have like 3 of those 97. So you will get a bunch of numbers like that, and then times 97 to the 3rd power and a bunch of other numbers. Okay, and let's take a look at the denominator. And 200 factorial, this is not in the 200 factorial, but 194, like if you just list those, all the numbers, 200, 199, 198, and stuff like that. So 194 is one of those, and then 97 is one of those as well. So this guy has 2 97s. Okay, so 97 squared and a bunch of other numbers, which I don't really care. And 100 factorial has only 197. But as you see, the numerator has 397, the denominator has also 397. So all these 97s will cancel, which means 97s will not be a factor of this division, because we have only 3 in the numerator and 3 in the denominator, so they will cancel each other. So 97 is not going to be there anymore. And this is not special actually. So you can do the same reasoning with this 89, because if you just multiply this by 3, you will get something still smaller than this. And then that will be, if you divide this by like 89, so you will get 3 point something, which means there are 3 of 89s. Okay, so we have 3 factors of 89, similar to 97. And the same thing with this guy, if you divide 200 by 89, so you will get 2 point something, meaning that you do have only 2 multiple of 89, which 89 is one of them. And if you double that number, so you will get, let me see, 8, that's going to be 2, 1, that's 16, and 178. So this one and 89. So these are the only 2 numbers that will be in this 200 factorial, which means you have 2 factors of 89 in this number, and then you have 1 factor of 89 in this number. So total, when you multiply, you get 3 factors of 89. So you will see all these will have the same number of factors in numerator and denominator, but how do we know when we are gonna stop testing, right? So we can actually easily do that, because if you divide 300 by 4, which is gonna be 75, which means anything that is larger than 75 will have 3 factor like this, like 97, 89, 73, 79, and some other like prime numbers. Anything larger than 70, like 5, will have 3 factors. So which means we can just say for anything, for any number, okay, let's say any prime numbers, I would say maybe. It does work with other, but since we are thinking about the primes, anything that is larger than or equal to 70, actually I will go with 76, because I said equal to. Anything that is equal to 76 and lesser than 99, you will have 3 factors of those primes in numerator, 3 factors of those primes in denominator, so which means there will be no numbers left with those prime numbers. They will cancel each other. Okay, so nothing works. I hope that really clear. So now we are gonna move on the numbers that is smaller than 75. That's gonna be prime number. So if you remember, 73 is the first number that we need to test, right? So if I take this 73, so let's go with that. So when I divide 300 by 73, which we usually use a notation, like we call this is floor, just to make sure like whole number to get. So if you multiply 75 by 4, that was 300, but since this is smaller than 75, that would be 4 point something. It's not gonna be 5, so, but if you floor that, so which is gonna be run into this, the largest integer smaller than the number is just 4, which means 300 factorial have 4 factor of 73. So you will get something like this. If you expand this guy, so you will get 73 to the 4th power with a bunch of numbers divided by, and then 200. If you divide this by 73, okay, so if you multiply this by 3, you get 200 something, which we don't have that. So that means this is 2 point something roughly. But if you take the floor, which means if you want to run this number to the largest integer smaller than that, so that will be 2, which means you do have only 2 factors of 73 in 200 factorial. So I can just write 73 to the 2nd power for this first guy. And then 100 factorial has just only one of them. So meaning that you have 3 factors of 73, but you have 4 factors of 73 in numerator. So 3 of those will cancel. You will get one more 73 in numerator. So which is why 73 is actually the largest number that you could have as a prime factor of this division. So I hope that makes sense. Okay, so that is the answer to this problem. And I'll see you guys in the next video.